We live on a planet whose crust is miles thick with rock. Rock is the basic unit that makes up our solid Earth. It supports everything, from the ground we walk on to our oceans, our deserts and mountains. When we talk about rocks, we're also talking about minerals. All rocks are made from more than one mineral. Geologists define a mineral as a naturally occurring solid that has a distinct chemical composition and consistent internal structure. Minerals can be elements or compounds. Gold, silver, and diamonds are 3 examples. The Earth is constantly changing, and so are the rocks and minerals it contains. They get redistributed and recycled over and over again in a process called the rock cycle. Over millions of years, rocks are continually made, changed, and destroyed. At the surface, people break down the Earth's rocks and put them to good use. Throughout history, we've learned to depend on them. Today, they help cover our roads, support our buildings, and decorate our lives. Forces of nature also take their toll on rocks at the Earth's surface. Wind, water, and gravity are always at work to wear down or erode the rocks around us. The results can be very dramatic. But for all of this destruction, new rocks are constantly forming. Some particles of rock get deposited and hardened into sedimentary rock. Others get buried, compacted, heated, and recrystallized beneath the Earth's surface. Temperatures are so hot at great depths in the Earth that rocks and minerals often melt and become liquid. Over time, the liquid cools, creating new rocks that eventually get pushed to the surface again. Sometimes this process happens quickly during events like volcanic eruptions and earthquakes. But most of the time, it takes millions of years. As a result of this ongoing cycle, the Earth holds a tremendous variety of rocks that differ in the minerals they contain. They vary in color, texture, permeability, and so on. Geologists study these rocks in search of valuable clues about the history of the Earth. Like rings in a tree, they hold information about past environments and the events that formed them. It's one of nature's most awesome sights. Here at the Grand Canyon, dramatic formations of sedimentary rock stretch as far as the eye can see. Located in the northwest corner of Arizona, it attracts tourists and geologists from around the world. Nowhere else is it possible to view so many layers of the Earth's geologic past. Its walls of ancient rock contain records dating back more than 1.2 billion years. That's nearly a third of the entire history of the Earth. But the Grand Canyon itself is actually much younger than that. Scientists believe that its creation began millions of years ago, when a powerful uprising of the Earth's crust began forming a large area called the Colorado Plateau. It lifted up rock that had been buried in the Earth for a long time. Around 5 or 6 million years ago, the Colorado River started carving a path through this uplifted land. tearing its way through the walls of limestone and soft sandstone, exposing the layers of ancient rock. What remains is a gorge of staggering dimensions. At 277 miles long, up to 18 miles wide, and a mile deep in some places, it's so large that it's even visible from space. Geologists work their way into the canyon to get a closer look at the ancient rocks. For some, like Matt Kaplinski, it's a dangerous but exhilarating job.
When the Colorado River carved down through the western edge of the Colorado Plateau, it laid open the geologic history of the southwestern United States like a book. This particular rock formation is the Mississippian Redwall limestone. 350 million years old. Fossils present in this limestone, they're abundant: crinoid stems, bryozoans, brachiopods, all sorts of good stuff. The Redwall limestone, as you can see, is actually a gray limestone. It gets its red coloring from the Supai Formation above. The red beds in the Supai Formation are rained on, and that washes out the iron oxides, pours over the cliffs of the Redwall limestone, and stain the cliff face a nice red color.
Minerals containing iron oxide add a spectrum of reds, yellows, and greens to the canyon walls. But geologists are even more interested in what lies within them. David Elliott descends further into the canyon to examine a deeper layer.
This is the Bright Angel Shale. 530 million years ago, this was at the bottom of a shallow ocean. These sediments were muds forming on the bottom, and large numbers of organisms lived in those muds. Although we very rarely see the remains of those organisms in terms of body fossils, we quite frequently find their traces.
The fossil traces he uncovers provide clues about how life on Earth and the environment changed over time. Today, this startling panorama continues to evolve. And in the process, it gives us an ongoing timeline of the history of our Earth. Situated in the Sierra Nevada mountain range in central California are the largest walls of granite in the world. Yosemite Valley has become a favorite playground for rock climbers. One of the most impressive walls they try to scale is the 3,600-foot El Capitan. It's a testament to the powerful force As a famous naturalist named John Muir once said, "No temple made with hands can compare to Yosemite." It's a temple that nature continues to sculpt today. There are 1,511 known volcanoes in the world. 500 are active, resulting in about 60 major eruptions a year. A volcano can have a lifespan of over 1 million years, unpredictable it can lie dormant for hundreds of years, then explode, sleep for another few hundred, and then erupt again. In 1943, in the small Mexican village of Paracatín, a crack appeared in a cornfield. It began belching smoke and ash. Within a day, there was a cone 40 feet high. A new volcano was born. Within a week, the cone rose 500 feet. Scientists came from all over the world to study the extraordinary eruption. After a year, the volcano had risen to 1,200 feet. It continued to grow and was very dangerous. Nine years after it was born, Paracatín covered 10 square miles of land and 2 villages. Then, the eruption slowed and stopped. The volcanologists packed up for home. It has not erupted since, but it's not dead. A volcano can threaten for millennia, but eventually it will die. When magma no longer seeps into the chambers, the eruptions weaken and stop. The heat remains much longer, warming the groundwater. Pools of sulfur, mineral deposits, geysers and hot springs are the last pale reminders of the volcano's long-forgotten power. Volcanoes act out in every possible way. Like a moody person, they can erupt in violence, or steam silently, lazily creep along, or self-destruct. A volcano's origin determines its temperament. Many volcanoes erupt along subduction zones. Here, the great tectonic plates of our planet's surface push against one another. Along this margin, where one plate is rolled beneath another, we find the most violent volcanoes. Explosive eruptions fit our image of a volcano. They create large cone-shaped mountains. These erupt when magma below forces its escape. Fueled by expanding gases and boiled groundwater, the excess heat blasts through. Volcanoes like this often have alternating layers of different volcanic materials: ash, cinders, and lava. These layered cones are called composite volcanoes. Hawaii isn't near the joining of two plates, but it's a hotspot of volcanic activity. What fuels it? The Hawaiian Islands are hotspot islands, created when a pool of magma breaks through a thin spot in the crust. As it burns through, the plate moves along 4 inches a year. One island is carried away to cool, while the next one is created, assembly line fashion. On the Big Island of Hawaii, Kilauea has been erupting since 1983 and shows no signs of letting up. It's an example of a second kind of volcano, the shield volcano. The central crater is called a caldera. It still steams, but probably won't erupt violently. Farther out, lava oozes and flows, creating new real estate as it cools. The wide flow is what creates a shield volcano rather than a cone. This new unstable bench is pure basalt. Sometimes the flows are only inches from the surface. The thick, honey-like lava, typical of Hawaii, cools into a harsh, barren environment that can take years to support life. Cinder cones are a third kind of volcano. Mexico's Paracutin is a dramatic example. Like composite volcanoes, they can be explosively violent visitors to the surface of our planet. They burst forth with enormous quantities of ash, cinders, and lava fragments. They rapidly build volcanic mountains, but never as wide as shield volcanoes or as high as composites. Cinder cone shape is determined by the size of the ejected material.